Hi students and friends, welcome to the channel Learn and Teach by Ayaz. So I will continue my video lesson for the topic periodic table, and in this lesson I'm going to talk about alkali metals and transition metals. So here we have learning outcomes of this video lesson. Describe the group 1 alkali metals, lithium, sodium and potassium as relatively soft metals with general trends down the group limited to decreasing melting point, increasing density, increasing reactivity. Predict the properties of other elements in group 1 given information about the elements. Describe the transition elements as metals that have high densities, have high melting points, have variable oxidation numbers, form colored compounds, often act as catalysts, as elements, and in compounds. So here's the periodic table. So on the left hand side of the periodic table, you see the group 1. These are the alkali metals. We have lithium, sodium, potassium, rubidium, cesium, and francium. These all are alkali metals as they are in group 1. So they have 1 valence electrons. 1 valence electron. Remember, group number tells us the number of electrons present in the valence shell. So here's the snaps for 2 metals from this group. On the left side, you see these are soft metals. This is of lithium. And on the right hand side, it's a cesium. Cesium melts on our palm because the melting point of cesium is lower than 30 degrees centigrade or around 30 degrees centigrade. So let's continue talking about these alkali metals. Alkali metals are on the extreme left side of the periodic table. They're shiny when freshly cut. They form cations of formula M+, which means they lose 1 electrons. They lose 1 electron to form positive ion or cation. The formula will be M+. M will be any metal from group 1. For example, it can be Li+, Na+, K+. What is common in these? They all are losing 1 electrons. So question number 1, what makes alkali metals different from other metals in the periodic table? Although these are metals, but they have some properties which make them different from other metals in the periodic table. If you can recall, metals are usually hard, but they are not hard. They are soft, very soft. Metals have high density, but they have low density. Metals have high melting point and boiling points, but these have low melting points. And the important point, the last one, they are very reactive metals. They react with everything. React with everything like oxygen, O2, H2O in air. They react with both oxygen and water in air. That's why they are kept in kerosene oil. They are kept in kerosene oil so that they will not react. Okay, here's the question. Why reactivity in alkali metals increases as we go down the group? So let's come back to this periodic table. If you look at this periodic table, and if we talk about the trend in alkali metals, as you go down the group from lithium, sodium, potassium, rubidium, cesium, and francium, the reactivity increases. Reactivity increases. So down the group, the reactivity increases. But why is this? Let's consider two elements from this group 1. I'm taking example of lithium. The proton number of lithium is 3, which means it has 3 protons and 3 electrons. So this will be the nucleus of lithium. We have proton and neutron. We have 3 electrons. So in the first shell, there will be 2 electrons, 1, 2. And the second shell, it will be 1 electron. Now after lithium, we have sodium. The proton number of sodium is 11, which means it has 11 protons and 11 electrons. This will be the nucleus of sodium, neutron and proton. First shell, there will be 2 electrons, 1, 2. Second shell, there must be 8 electrons, 1, 2, 3, 4, 5, 6, 7, 8. Now 1 electron is left. In the third shell, we have 1 electron. What about potassium? The proton number of potassium is 19, which means it got 19 protons and 19 electrons. For potassium, I have to make 3 shells. First, I have nucleus, neutron and proton. This is the first shell, second shell, and third shell. Now I'm going to place all the electrons. In the first shell, there are 2 electrons, 1, 2. In the second shell, 1, 2, 3, 4, 5, 6, 7, 8. 8 plus 2, 10. 18 minus 10, and 19 minus 10, 9 electrons are still left. So in the third shell, there will be 8 more electrons. 1, 2, 3, 4, 5, 6, 7, 8. Now 1 electron is left, which will come in the fourth shell. You see the size, the atoms become larger and electron shells increase. See the increase in electron shells and atoms become larger. So the attractive force of nuclei for valence electrons decreases. So as you go down the group, in this group, the attraction for the valence electron decreases. Attraction of nuclei for valence electron will decrease, which means it becomes easier for a metal atom to lose its valence electrons. It becomes easier to lose valence electron. That's why the reactivity increases down the group. In fact, down the group, we have highly reactive metals in the periodic table, like cesium. It reacts explosively. Both rubidium and cesium, both of these are highly reactive metals. So let's talk about some reactions of alkali metals along with observations. We have a reaction with air or oxygen, then we have reaction with cold water and with chlorine. For lithium, it burns with red flame on reaction with oxygen and produces white solid. And when lithium is reacted with cold water, it floats on water, then it reacts quickly, bubbles of gas will be produced. With chlorine, it burns with bright flame and white solid will be formed. What about sodium? Sodium with air or oxygen burns with bright yellow flame and white solid is produced. With cold water, it also floats on water, but reacts fast as compared to lithium. Smoke will be produced here. We will not get any bubbles, we'll get smoke. Instead, we'll get smoke. What about chlorine? When it will react with chlorine, it burns with bright flame, just like lithium. Again, white solid is produced. What about potassium? Potassium now burns violently with lilac colored flame and white solid is produced on reaction with oxygen. With cold water, it reacts violently. So just like lithium and sodium, it also floats on water, but it reacts violently. You see the things are getting quicker and faster. There will be a violent reaction. Sparks will be produced. And with chlorine, it burns vigorously. With chlorine, a white solid will be produced. Now for the rubidium and cesium, you can easily predict the reaction. There will be explosive reaction. Explosive reaction. Or you can even write destroying the whole apparatus. In case of reaction with water, any gas produced will catches fire. Now here are some reactions of alkali metals. M represents any alkali metal, like you have lithium, sodium, potassium, rubidium, cesium, or francium. Now, if you want to react lithium with oxygen, the reaction will be 4Li plus O2 gives 2Li2O. How you will get the formula Li2O? This is lithium oxide. Recall the concept of valency. Lithium is in group 1, na? So the valency of group 1 will be +1. Oxygen is in group 6. The valency of group 6 is -2. Ignore the charges. 1, 2. Now these will be subscripts. Subscripts will be exchanged. So you get what? Li2O. In this way, you'll get the formula Li2O, lithium oxide. Now, when you react these metals with water, you'll get two products. You will get metal hydroxide and hydrogen gas. This is gas. Hydrogen gas. So, if you are reacting sodium with water, what you will get? Na plus H2O. You will get metal hydroxide and hydrogen gas. What will be the formula of metal hydroxide? Sodium belongs to group 1. So again, the valency is +1. What about the charge on the hydroxide ion? Hydroxide ion, the formula of hydroxide ion is OH. It carries -1 charge. Ignore the charges. Now these subscripts will be exchanged. So it's very simple. You will get NaOH. Sodium hydroxide. Now I will balance the equation. So I will write 2 here, 2 here, we have 2 here. Now it's balanced. The last reaction is with halogen. What is X? X can be any of these halogens. Halogens are group 7 elements. Fluorine, chlorine, bromine, iodine, or astatine. Now if you react potassium with chlorine, what you will get? K plus Cl. You can't write Cl. Halogens, they all exist in diatomic state. So you have to write Cl2, not Cl only. What will be the formula of the compound formed between K and Cl? K belongs to group 1. The valency will be +1. Cl belongs to group 7. The valency will be -1. So ignore the charges. Subscripts will be exchanged 1, 1. So in the end, you will get KCl. This is potassium chloride. Now let's balance the equation. Write 2 here, 2 here. Now it's balanced. In the same way, you can predict the reactions of other alkali metals with oxygen, water, and halogens. Now let's talk about the trends down the group. So there's a decrease in melting point. There's also decrease in boiling point. What is ORA? ORA is or reverse argument. You can write the reverse argument. When you say reverse argument, so it means we'll go up the group. So up the group, what's happening? Increase in melting point. Increase in melting point if we move up the group. Now the other trends, there's an increase in density down the group. There's increase in the activity down the group. There's decrease in hardness. You can say there's increase in softness down the group. So you can write there is increase in softness. Again, you can have any reverse argument like ORA or reverse argument. Now here's past paper question. Chemical properties of some group 1 elements are shown in the table. So here we are having element, reaction with cold water, then we have reaction with oxygen, flame test color. Number 1, add to the table the flame test colors for sodium and potassium. It's very easy. For sodium, you get yellow color. For potassium, you will get lilac. Lilac is purplish. The predicted reactions of rubidium with water and with oxygen. So you can write explosive reaction, as I have already mentioned, explosive reaction. So it will also form a colorless solution. The statement will be same, forms a colorless solution. With oxygen, again you can write explosive reaction, and it will also form oxide layer. Name the gas produced when group 1 elements react with water. I have already discussed. It is hydrogen gas. So you write hydrogen here. Now let's talk about transition metals. Transition metals. Here in the middle, they are between group 2 and group 3. This is group 3 and group 2. So these all are transition metals. You have notable elements of transition metals like copper, zinc, iron. These are very common. Gold, silver, these are also common. And other transition metal which is used in thermometer, it is mercury. The symbol of mercury is Hg. Here it is mercury. So here are 2 transition metals. This one is copper. These are copper. You know, copper is used in the wiring. And this is rusted iron. It's actually rusted iron. It's not pure iron, rusted iron. It's rusted iron ladder. Okay, now transition metals, they possess all key characteristics, that properties of metal, which means they are hard, high melting point, melting or boiling point, high density, malleable and ductile. You know, the malleable can be changed to different shape, and ductile, good conductor of heat and electricity. Good conductor of heat and electricity. Good conductor of both heat and electricity. Now, what makes them different from other metals in the periodic table? They have variable oxidation states or numbers or valencies, except zinc 2+. So variable valency means they have more than one charge. Like copper, it can have +1 and +2. Iron, it has +2 and +3. They often form colored compounds. Cu2+ is blue in color, Fe2+ green in color, Fe3+ reddish brown, etc. There are other colors for the other transition metals. We don't have any details. We are limited to copper 2+, Fe2+, and Fe3+. So transition metals or their compounds can act as a catalyst. What are catalysts? Catalyst increases the rate of reaction. And you know that how they do this, they decreases the activation energy, or they provide the alternative route to the. Here are some compounds of transition metals. For example, you have compound of chromium. This is chromium compound. Potassium dichromate, it's an iron compound. It is iron 2 sulfate. It's cobalt compound. Symbol of cobalt is Co. Cobalt 2 chloride. It's copper 2 sulfate, blue in color. It's a copper compound. You have nickel compound, nickel 2 sulfate. You see, in all of these, except the first one, they have shown the charges on transition metals. The reason is that they have variable valency. That's why it's very important to show the charges or valencies. So here we are having some uses of these transition metals. which is in your syllabus. For example, V2O5. It's a compound of vanadium. It's vanadium pentaoxide. It's used as a catalyst in contact process. Contact process is used for preparing sulfuric acid. And during the preparation of sulfuric acid, there's a step in which there's a conversion of SO2 into SO3 taking place. It takes place in the presence of catalyst V2O5. Now, there's another process to make ammonia. It's known as Haber process. And in Haber process, iron is used as a catalyst. So in manufacturing of margarine, we use nickel. And when you are interested in manufacturing O2 from H2O2, H2O2 is hydrogen peroxide, use manganese dioxide or Mn4 oxide, MnO2 is the formula. So here are more applications of these transient metals. There are some different things used, like for example, a screwdriver. This is screwdriver. This is screwdriver. These are keys. This is a scale or saw kind scale. This is a nut opener, tire nut opener. Here are some wires. So transient metals are also used in this. So we have past paper questions. Describe two differences in the physical properties of chromium and sodium. Looking at the position of chromium and sodium, chromium is a transition metal. So you can write any of these differences between these two. We have chromium, sodium. You can write chromium. It is hard, form colored compound. Variable valency. Used as catalyst. These are differences. So for hard, you can write here for sodium. It's soft. It's not colored. It's not colored. It does not form colored compound. It has fixed valency. That is one. You can also write other points like chromium have high melting point, high density. Sodium got low density, low melting point, etc. Here's another question. Potassium reacts with water to form a gas which pops up with a lighted splint. Complete the equation for this reaction. There's a reaction. It's potassium plus H2O gives 2 KOH plus gas produced in this reaction is H2. This is a gas which pops up with a lighted splint. Now let's balance this equation. I will write 2 here. Now this equation is balanced. If you count the number of atoms, potassium, 2 on the reactant side, 2 on the product side. What about hydrogen? 2 to the 4, 4 on the reactant side, 2 plus 2, 4 on the product side. What about oxygen? Oxygen is 2 on the reactant side and 2 on the product side. It's balanced. Thanks for watching. Press like, share my videos, give comments. For more videos, subscribe to my channel and press the bell icon.